This is Christopher Sernaque hosting episode 23 of season 3 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcast, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Today on Current Topics in Science, we have the honor of hosting Charlie Wolcott. This is the second part in a 4-part series with Charlie. Charlie studied computer science at the University of Texas at El Paso, and he's certified to teach math and physics for both middle and high school. He's also a graduate from the Sharp Institute for Biblical Worldview Studies of the Creation Truth Foundation, where he was commissioned to teach about the importance of having a biblical worldview. Charlie has always had a passion for the Lord, and he was raised in the mission field. He's helped his parents for over 2 decades as they served with international family missions, and he is the leader of a Bible study group at his church. He's a member of Worldview Warriors, and he speaks at conferences, church events, and Christian schools. He's a teacher and an author of several books, such as 10 Reasons to Believe the Bible and The God of the Psalms. Charlie has Asperger's syndrome, which is a high-functioning form of autism. When he was 6 years old, he was told that he'd never run, and that he'd probably never live on his own, drive, or go to college. His testimony did not turn out that way, though, as he's currently teaching AP Physics, which is considered to be one of the most difficult of all AP classes. And so by grace, Charlie has done all of these things and more to the glory of God. And now, without further ado, good afternoon, Charlie. How was your day, and how are you doing?
It's been great so far, and looking forward for round 2.
Awesome, Charlie. It's wonderful to have you back on again. And since this is Current Topics in Science, we're going to quickly look at this week's current topic. So in each part of this 4-part series, we're going to be looking at an article called Radiometric Dating Puts Pieces of the Past in Context. Here's how. The article continues by saying, despite the potential challenges, scientists have used radiometric dating to answer all sorts of questions. Researchers use lead-lead dating, which looks at 2 lead isotopes, both daughter products of the uranium isotope, to analyze an inclusion inside an ancient meteorite. In 2010, they reported the tiny bleb was about 4.568 billion years old, making it one of the earliest building blocks of our solar system. The team used an aluminum-magnesium dating technique to confirm that great age. Others have used similar techniques to estimate the age of the Earth's oldest known rocks, about 4.4 billion years, and when plate tectonics might have begun more than 4 billion years ago, according to one study. And even though some of these techniques are estimating ages billions of years in the past, they can do so with error bars of only 100,000 years or so, says Marc Caffé, a physicist at Purdue University in West Lafayette Industries. I marvel at the precision these chronometers have, he adds. So Charlie, it sounds like those physicists are very confident in their research, but I'm wondering, can you tell us, in general, how is it that one can determine the scientific rigor of a process or a method?
So there's quite a bit to discuss on this thing, and that's really what this whole session is going to be about. A subtitle they could call it is a test case, and I'm going to define what a test case is here in a few minutes. But there's a couple things that to address in this quote that really kind of stand out. Okay, so one of the things is that they discovered a rock that they dated about 4.6 or 4.568 billion years old. And then they say that they can do these with error bars of only about 100,000 years or so. So let me go find but let's do a little math here. And how much of an error factor is that? So if you're going to say like 1 billion years, let's just say the rock is just 1 billion years, and they have a 10,000 year error plus or minus 8 error factor. That's a basically an error factor of within 1% of 1%. And that sounds very impressive, but that's actually not their typical results. Okay, if you look at other samples with their results, and a prime example of this is one of the very few places where we have publicly actually seen the full table of dating results of a sample was from the Apollo 11 moon rocks that were brought down from the moon. And there was one sample I saw that was 2.7 billion years plus or minus 0.7 billion years. So this rock, according to their dating method, could be as old as 3.4 billion years or 2 billion years, which is a 25% error factor, not 0.0001% error factor, 25%. They really don't have the accuracy that they want to boast about. What they're doing is that they are cherry picking their best results and saying we can get as close to this as possible, but they're not looking at the full data, which actually showcases things that are much worse. And whenever we see the full results of these dating methods, the error factors are all over the place. And that's actually part of the research that I've been wanting to develop. And I'll talk about this in more detail in our fourth session tomorrow. But so the real question, though, is how can we test these methods? How can we see how strong and robust they are? That's what we're really asking about here. Okay, so in a way, I can't answer your question without getting ahead of myself and getting ahead of our interview. But let's lay down some little groundwork about some scientific experimentation and some keys and a key science term that's pretty much all but forgotten today. And that key concept is precision versus accuracy. Okay, so when you talk about precision versus accuracy, usually what a science textbook would give you is a bullseye with darts hitting the bullseye. So if you have a result that has low accuracy and low precision, the arrows that you're aiming at the bullseye for are going to be all over the place. You might get one that hits the spot. You might get one that gets all over the place, but you really have no way of actually knowing what's actually whether you're really hitting the target or not. Okay, you can have low accuracy and high precision. High precision means you're hitting the same spot. Accuracy means you're hitting the target. So if you have a low accuracy, it means you're not hitting the bullseye. But if you have high precision, that means you're hitting the same spot each time. And that's really what this article is talking about. They're getting high precision. But the real question we have to ask is, are these methods accurate? Are they actually hitting true ages? Okay, you can reproduce the same results all over and over and over again. If your calculator is calibrated to say 2 + 2 = 7, you're going to get 2 + 2 = 7 every time you crunch it in your calculator, but you're going to get a wrong answer every single time. Okay, you can have high accuracy and low precision, which means you're shooting all around the bullseye, but you're not necessarily hitting the bullseye each time. And the truly good methods, the truly good and tested methods, have both high accuracy and high precision. And what's happening in a lot of our scientific investigations and studies these days is that they have made these two terms interchangeable. Where now where if you're precise, that means you're accurate. And the middle schools the middle school students are supposed to be taught this difference. Yet the PhDs and the masters are saying they're interchangeable. And then there's an issue of calibration. A friend of mine, Alan Dunkley, who's a really good ally for us, he's written a book called Scripture and Science, and it's one of the most simplistic books I've read that addresses the key issues about origins from both a scientific and theological perspective, and it's very understandable for a layman. So if you haven't checked that out, that's a really good book to check out. Is Alan Dunkley's Science with Scripture, Confirmation or Conflict or Confirmation. But one of the things he mentioned to me in dialogue is that in all true science experiments and stuff, we have formal scientific measurements. In a SI system, we have meters, seconds, kilograms, degrees Kelvin, coulombs, lumen, moles, and these are all the formal definitions of measuring distance, time, mass, temperature, electric charge, luminosity, and amount of substances. Okay, and these are the 7 fundamental physical measurements that we have on planet Earth. And so we have to find we have to find formal measurements of these standard quantities, and that is that is the basis for how we use all of our experimentation. Okay, so so we all have our own measuring tools. I've got meter sticks in my classroom. I've got weigh scales, but they only work if they accurately measure what a meter is, if they accurately measure what a second is, if they accurately measure what a kilogram is. So if you have a meter stick and it's missing 2 centimeters, you could still use it, but it's always going to give erroneous data unless you compare it to the known standard and calibrate it for the missing data. Okay, so let me say that again, just so that the audience, our audience is clear. But if your meter stick is missing 2 centimeters, or it has too many or has 2 extra centimeters, you can still use that measuring tool, but you have to understand that's always going to give wrong data unless you compare it to a known standard and then calibrate it for the data that's wrong. And what we're going to see here is that the methods that used to determine these deep time ideas, especially radiometric dating, they never actually went through any calibration process to test with actual historical data. There may be some cases where they actually tried, but in order to get these methods established and before they were made to public use, there is no known experimentations that I have been able to find where such tests were being done. The closest example I can think of would be a guy named Darren Pohl, who in 1984 he tested several historical lava flows where we know when that volcano erupted, and he did come up with some results. Some seemed to be accurate, some were off base. But what's interesting is that no one has ever been able to replicate his results. So that catches my attention. Have these methods that show that absolutely prove deep time in the minds of the media and in the minds of many of the people that we talk with. Did they actually go through any rigorous testing? Okay, were they actually compared with concrete facts? And I will make the argument that they were instead only calibrated to the artificial man-made geologic column, which before these dating methods, the dates given to these rock layers were simply made up. And the only way that radiometric dating methods can work as they are proclaimed is by comparing it to the known history, to the known paradigm that deep time gives us. So our opening question, how can we test the scientific rigor of any method or any process? Okay, let's compare it to known markers that anyone can test and validate. And then we can do some test cases, which is the subject of our sessions here.
You know, Charlie, that actually brings to mind a quote from Leon Welsinter. He was a humanist. He said this during a commencement speech. He said, "Scientism is not the same thing as science. Science is a blessing, but scientism is a curse." So, Charlie, in our first segment together, we covered what the fundamental principles of science are. And you were just talking about scientific rigor. And so now I'm wondering, while we're on this subject, you mentioned a test case study. So I'm wondering, can you explain the purpose, the design, and the nature of scientific experimentation?
Scientific experimentation is the heart of all science. And you'll be hard-pressed to find anyone who claims to support science to disagree with this. But Nikola Tesla, who I'm not sure when he gave this quote, but he lived in the mid 1800s and all the way to the mid 1900s. But he made this very profound statement. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. About a month and a half ago, here in El Paso, we did a creation conference. And some apologists and some other speakers and church leaders and I, we put this together. And one of my presentations was on the Big Bang Theory. And one of the things that I pointed out about the Big Bang Theory is that there's absolutely no use of observation to actually showcase how the Big Bang Theory was developed. It was purely off mathematical expressions and mathematical constructs. Okay. Now, what's interesting is that each of these equations that they use, they were based off scientific experiments, but the scientific experiments apply to the situations where the experiment was done. They do not necessarily apply to other situations. Okay, they can, but not necessarily. So what we end up with is they basically have this model of what would need to happen for all this to happen purely by natural models, and that's how they build these structures. Okay, and that's also how they did the radiometric dating. Okay, and I mean, I'm going to have a number of skeptics that would come out and say like, that's not what we're doing. That's not what we're doing. But I'm not. I don't. I am not. They're not presenting to me the actual scientific experiments that are going to give me any reason to believe what they're saying is valid. Okay, Louis Pasteur, a very famous chemist and scientist from the 1800s. He's the one who he discovered the pasteurization process. He's also the one that formally refuted the idea of abiogenesis. Okay, and he said this: "Do not put forward anything that you cannot prove by experimentation." Okay, and of course, the context here, he's talking about if you're going to call it science, do not put anything forward that you cannot prove by experimentation. So experimentation is the absolute critical thing for if we're going to call it science. If you don't have the experimentation, you can call it something else. There are things we cannot prove by experimentation with creation. And so I'm not going to call that science. I'm going to call that biblical history because that's what the Bible describes. And so it's critical that we make this distinction. So there are 5 major steps, and of course the order kind of can vary from source to source. But the 5 major steps are hypothesis, and the hypothesis is what do you want to test, and what outcomes are you expecting. And this is a big one. It must be specific. One thing that I've noticed with all these deep time models and proclamations, anytime they actually do any kind of hypothesis or testing or predictions, they're always very vague. Almost anything could fulfill that with given enough imagination and crayons. Okay, okay, and so that's the hypothesis. You should expect specific results with specific reasons for those results. That's one thing we will not see with any of these deep time models. Observation. What do you actually see happening? Okay, does your model, does your construct, does it actually reflect what we are seeing happening? Okay, and then I'll add another, for this purpose, I'll add another side note to this. Is what we're observing in the lab reflecting what actually happens in the real world? Because there's a big difference between those two. Okay, experiment. Design an experiment that tests that specific hypothesis, and that's usually pretty smooth. Okay, most people don't have issues with that, except when they don't do the experiment; they just do the math calculations, and then we get where the real worldview issues come in. The interpretation: what did the experiment showcase, and what did it mean? Do you accept the data? Do you reject the data? When Mary Schweitzer, and I know she gives creationists a lot of flack because she thinks that we're misrepresenting her. But it is known fact that when she discovered this soft tissue in that T-Rex fossil, her supervisors absolutely refused to look at it. Okay, because it raised a question to deep time ideas. She had to fight immensely just to get her work published. And there's even a 60 Minutes episode where she showcased like how difficult it was to get published. And so the interpretation plays a big role. And then, and what's also interesting with just using that as to continue that example, it also was really interesting how the questions that came about Schweitzer's find never was, is the T-Rex fossil that old? The question was, how did this tissue preserve that long? They didn't ask the most obvious question. How old is that bone really? Okay, so that's all based on interpretation, which is based on our worldview, which we covered in a lot more detail last session. And then there's the report side. Okay, so did the experiment prove or disprove or support or reject the hypothesis? What can be done for further study? What went wrong? What went right? And one of the things that I also noticed, especially with deep time, is that the report is always very selective about what the data actually gave. Okay, and usually what we see in the scientific papers is the data result that fits the story that they want told, but not all the data. Okay, so that's what a scientific experiment is, and when it comes to origins, there's a lot of things where it doesn't and cannot fall through the scientific experimental process. So when you design an experiment, one of the things that we do in AP Physics that regular physics doesn't cover it as much detail, but we actually teach our students how to design an experiment. Okay, and so what I teach them is that after numerous observations as to how things operate, they should know the relationship between quantities such as mass and time, or distance and time. Okay, and from there you can develop things like forces, energy, momentum, and we build on from that. Okay, and so if you change one aspect of a movement, it should have an effect on another on one quantity. It should have an effect on another quantity. So if you pull with a greater force, you should see a bigger acceleration because according to Newton's second law, force equals mass times acceleration. And so we do use mathematical equations for this. Okay, and then what we do is what we design an experiment to test a particular situation, and then often this involves deriving a mathematical expression for that particular situation. Okay, and it's usually under a major theme of like sum of forces equals mass times acceleration, or conservation of energy, or conservation of momentum. That's usually what we deal with. But they have to figure out what should the mathematical expression for this particular experiment look like. And so there is valid mathematical manipulations. However, those mathematical manipulations have to match something that can be tested, something that can be observed. Okay, and usually what we'll do is that we'll show them how to graph their data, and then they find the relationship by either using the slope of the graph or area under the curve. So, and then another aspect of this, a big flaw that's taught in many schools, is to do repeated trials to showcase the validity of the experiment. And by doing that, they just repeat the same experiment. Okay. Now you can help eliminate or discover error factors by doing it this way, but that's actually not the best way to do it. What you want to do is you want to repeat. Okay, so you do want to repeat the same trial to account for error factors, but what you really want to do is you want to change values such as mass or distance to get different velocity or different energy readings, and then see if you're actually getting consistent readings according to the equation. So one of the labs we do is to find the coefficient of friction between two surfaces, and one of the labs we did this year was we call it the mule of a shoe lab. And so basically it's the idea of figuring out what is the coefficient of friction between your shoe and the surface and the carpet. Okay, and so we have a standard equation for the force of friction, where force of friction equals the coefficient of friction times the normal force. And I know this is technical for the non-science people, but the whole idea here is that we can't really just pull our block or pull our shoe at a constant rate and then do some math. What we need to do is we need to test multiple masses. Okay, and so the heavier the shoe, it should take more, or the more mass of your shoe, the more mass of your object, it's going to take more force to pull that. Okay, and so, but the coefficient of friction is ultimately independent of that. Okay, so the friction and the amount of force of grip force between the floor and the surface of the object will change accordingly. And so by testing multiple masses, multiple weights, you can still validate, you should get the same reading of the coefficient of friction if that equation is legitimate. Okay, and so if we're to graph this, and I have a sample graph here, so comparing the weight versus normal force, you should get a constant straight line, which is what we teach our AP students to do. So in order to do proper scientific experiments to find out the relationship between different quantities, you got to be able to change different parameters, and if things are operating at a constant rate, then the rate should be shown by having different measurements. Okay, and so when we're dealing with exponential decay, one of the things we have to be able to do, we have to be able to measure different masses. Okay, does a bigger mass decay at a faster rate than a smaller mass? Okay, so we have to change those values, and if the decay rates are at a constant exponential decay rates, that should show. My question is, did these methods, when they were being established and developed, did they go through this kind of process? I am I am very skeptical about that. So what we can do to kind of test this or validate it is that we can give them what we call a test case.
Well, Charlie, I really appreciated your answer, and I'm sure that as a science teacher, this subject is near and dear to your heart. And by the way, besides teaching AP Physics, I know you also studied computer science. So now, in my mind, it seems as though what is called a test case that you just mentioned, it's similar to a scientific experiment. But can you explain further exactly what a test case is in light of our subject on radiometric dating?
Yes, so the test case, it's a very specific type of experiment. Unfortunately, this concept is pretty much all but ignored in establishing scientific models or principles. I have never heard of this concept in a general science field such as biology or physics or chemistry, but I hear it all the time in computer science and in engineering programs, and it's absolutely vital to understand this notion. So, what a test case is in a computer program for computer programming, a test case is designed to intentionally break a system for the purpose of looking for weaknesses in the program or the technology or the method. Okay, so it basically answers the question of what could go wrong and can our system handle it. So let's go through some very simple examples. If you go to Home Depot and you go through their aisle on with ropes and cables and chains, each rope and cable has a weight limit on how much they can hold, how much they can pull before they're going to break. So these were things that were tested. So in computer programming, the issue is a little bit more severe. So I mentioned the calculator before. Okay, so we know mathematically that 2 plus 2 equals 4, and so the calculator has been programmed to take 2 plus 2 equals 4, and that's what happens when the calculator is operating functionally. But what if the user does a typo and they put in 2 plus 2 equals 3? Or what if they put in 2 plus dot equals what? How would the calculator handle that? Okay, so this is an unexpected input, and it's a very realistic thing that students that anyone using a calculator will do. But the programmers have to be able to know that people make stupid mistakes. Can the calculator handle that? The calculator has to be able to handle any possible input. So we know mathematically you can't divide by 0. So what happens if you put in an expression in a calculator that ends up with a denominator equal to 0? The calculator, if it's designed properly, has to throw an error flag. But what that means is that the programmer has to actually put in an expression that 2x minus 2x equals 0. And if you're divided by 2x minus 2x, then it's got to throw an error flag. And it says like error, can't calculate that. Okay, so that's the main idea. So in my collegiate programming career, and it was a great joy to get a program to do what it was supposed to do. But was it robust? Okay, did it have bugs? Did it have errors? We know that our computers have a number of errors, and technology would not be popular. They would not be well used if they continually came up with errors that would crash and burn and break down. So if I program just enough to make it work only in the specific situations where I said it would work, would that technology make it to public use? And the answer is pretty much no, it wouldn't, because this guy be able to handle data that it wasn't expecting. Okay, so would this technology catch an error? Would it break down? Would it crash? And how it handles unexpected data determines how robust the system is. One of the great things about our DNA is that is how robust it is. Even though we've had all these mutations that have been adding up over the centuries and millennia, our DNA is so robust that it's been able to keep us actually where we're still functional. So here's an example that I use to kind of showcase what happens with dating methods. And so if you're around any area where there's a lot of high truck traffic, you're going to come across a truck weigh scale. Okay, so these are scales that are meant to handle weights in the multiple thousands of pounds. Okay, so if you were to put a feather on that scale and it registers as 200 pounds, what would you do? Okay. Obviously, that scale's not reading the data correctly, and that's the kind of thing that we're finding with radiometric dating methods. Okay, methods like the potassium argon method, they're not designed to handle rocks and lavas much younger than 100,000 years old to a million years old. Okay, because there's not enough time for argon to collect. And so we'll address the Mount St. Helens issue in just a moment here. But according to Kevin Hankey at No Answers in Genesis, objecting to the Mount St. Helens study, that this is his argument. But and so I'll address that in more detail in a moment. But how these methods respond to fresh lava? Okay, so if the methods are robust and they know that shouldn't be able to handle that stuff, it should it should get to a point where the method would produce a result of error or too young to date or not enough samples or whatever, but it shouldn't come back with large normal readings. So this would be a perfect test case, and it's something that the secularists have obviously not thought of doing prior to the popularization of these methods. And I'll also argue it's one that they are afraid of doing, and then they object to doing. And so my question to that is, like, why are they afraid of it?
Definitely. So it sounds like you're saying that these several test cases, they've given grounds for skepticism of radiometric dating. So can you please explain a little bit more about what test cases were being carried out and then what the results would be?
So there are several test cases that the secularists have not done. These test cases, they've not. The only one I can think of, was I mentioned in the intro, was a guy named Darren Pohl, who in 1984 actually did some radiometric dating testing on lavas that came from eruptions where we know when that happened. But there was one big group that I went to go do a lot of testing on these things, was called the RAID Project. Okay, and mostly from the Institute for Creation Research, and it's called Radioisotope and the Age of the Earth. And they included scientists such as John Baumgartner, Larry Bardeman, Russell Humphreys, Andrew Snelling, Steve Austin, John Morris, Stephen Boyd, and a couple others. Okay, all of these except for one guy, I think, was a PhD. Okay, in some kind of physics, geology, or engineering. Okay, so these guys knew what they were talking about, but they went to go check out these dating methods. Okay, I don't think this was an official part of the study, but Steve Austin, who was part of the RAID group, in 1996, he went to go gather samples from fresh lava that came from Mount St. Helens, from a lava dome that was formed in 1986, just a few years after the main eruption. So he sent it to a lab to be dated using the potassium argon method, which at that time was a very popular method. It's still being used today, but it was extremely popular back at that time. Okay, so he gave the lab what type of rock it was, and he told them to expect low argon, which is the daughter isotope. Okay, so he told the lab like what kind of rock it was. He told the lab that it should give young results. Okay, but however, he did not tell the lab where it came from, and there's a good reason why. Because if he did say where it came from, then they would automatically know what was going on. And the results came back. It ranged from 340,000 years to 2.8 million years on rocks that were only 10 years old. Okay, the secularists have a lot of problems with this. So we're going to look at some of their objections. Okay, I mentioned Kevin Hankey from No Answers in Genesis, and his main argument was these methods are not meant to be used for anything under 1 million years old. And my argument to that one is like, well, that's actually the point of Austin's study. Austin knew that these methods were not meant to be used for such young samples. That was the point of it. It's called a test case. He wanted to see if these methods would pick up on those readings. If these methods were robust, if they had been properly tested and able to account for such a thing, the dating methods would have produced an age of 0 or too young to date. It definitely would not have given a range well into the usability range of the system. And what's interesting is that After this study, there are many labs that refuse to take that take any sample that's less than 1 million years old for KAR dating. So what we see here is that it's what we call affirming the consequence fallacy. It's where they have to know their answer before they do their scientific experiments. One of the other images that I use to describe this is influencing the witness, which if you do that in a court of law, you're held for contempt, you're arrested, and any evidence that comes out of that is thrown out. And yet that's what has to happen on these dating methods. But I have the form for sending a submission there. And one of the boxes that they have to fill out is not necessarily required to fill it out, but it's one of the boxes is estimated age range. So before they test it, they have to know what kind of age they're expecting. And so that automatically tells me that they're not testing for any validity here. They're testing to basically confirm their story, which is, again, what this whole debate's about. So they got some other objections. One of the big ones from this one's from the Grand Canyon Monument to an Ancient Earth is that all these dates proved is that these particular lava chunks were recycled and they didn't actually form in the lava. They were much older anyway. So what they're saying here is that that as the lava from Mount St. Helens was bubbling up from the 86 or the 1986 geologic movements, the rocks that Dr. Austin found just happened to be the ones that never actually completely melted, and didn't, and so the clock never got reset, and so these rocks are always much older anyway. So that's maybe a plausible scenario, but how could you prove that? How could you actually showcase that's what happened? So what we're seeing here is that this is just a story that they're saying to explain away the data. If the results agreed with their story, they wouldn't think about this. And also, this would assume that Dr. Austin was fortunate to just happen to by chance select a few rocks that would not have completely melted in the lava. So what are the odds of that happening? And there's some other objections that they give. So they say Dr. Austin lied about where he got it from. It was a dishonest test. Well, it was let's give them the benefit of the doubt about that. But if we're just measuring isotopes, this part wouldn't matter. A robust system would catch it. Okay, and again, there's still an easy way to test these claims. Run the experiment yourself. Pull out lava from that 1986 lava dome, which is now 35 years old. Should be a little bit easier to find out what's going on. But why aren't the scientists who are objecting to this? Why aren't they doing the data themselves and proving that Dr. Austin was wrong? Where's their experiment? They'll say that the lab didn't know what to do with it. Again, if we're just measuring isotopes, this wouldn't matter if the lab didn't know what to do with it. A robust system would catch that. Sometimes they'll throw in, well, the lab's equipment was dirty. Well, it's interesting how that always happens when the data is conflicting with the story that they're trying to tell. Okay, but if that's the case, which Dr. Austin didn't actually run the testing, that's the secular models. So if the lab equipment was dirty for that test, what makes them clean for others? Another objection that Dr. Austin should have known that in such fresh lava that there's excess argon and it would naturally give off false results. But actually, the method demands that the fresh lava is argon free when molten. That's what the method demands. And then they'll even say that secularists have boasted this boasted that they've known that there's fresh lava has excess argon for decades. So my question is, why are they still using the method? Okay, and again, what's not being said, what's not happening is the secular models defending these methods going to test the lava themselves to showcase how the methods are supposed to work. But another test case that's been a big one that I've been having fun with is that the Ewing Carrot lava flows at the Grand Canyon. Okay, and these lava flows have posed a very big problem for them. So I got a diagram here where we at the very bottom of the Grand Canyon we have Gardner's basalt, which is Precambrian, and they have dating range. They have the dates of these lava flows dated from really about 715 million to about 1.1 billion. Okay, and then So that's at the very bottom of the Grand Canyon, underneath all of these layers. And then they have basaltic rocks of the Uinkaret Plateau, which is at the top of the Grand Canyon and flowed into the Grand Canyon. Okay, so that means that these lavas flowed after the canyon was carved, and that's a very critical point. Okay, some potassium argon models dated from 50,000 years to 17 million years, but their main other models are from 1.2 billion years to 2.6 billion years. And so what they have here is the rocks that were at the very bottom of the canyon, underneath all the layers, is younger than the lava that's on top of the canyon. But here it gets even better than this. According to the secular models, the Grand Canyon either was carved out or finished carving out about 6 million years ago. And so they have lava that's flowing into the canyon over the edge that's dated to be well over 1 billion years old in a canyon that's only 6 million years old. So I'm seeing some major discrepancies here. I'm seeing some major problems with the thinking here. Okay, and this is just comparing their own story to their own data to their own story. Okay, this has nothing to do with young Earth creation models. This is their data, and it's not my fault that their data doesn't agree. Okay, don't blame me for pointing it out. So, how do the secularists answer for this? Okay, so data like this, they will say that this is like these are just like exceptions. These are outliers, but the other dates really don't reflect this. But what it seems is that the common practice is that the secularists will cherry pick data that support their story. But if they're going to do that, if they're going to do that to support their story, then it's fair game for us to cherry pick dates that show that their story is wrong. But again, what I've noticed here is that they're not following the evidence; they're following the story. They're following the paradigm. I don't think they actually care about what the data results say, as long as it reflects their story.
So if I'm understanding you correctly, it sounds like you're saying that the radiometric dating methods are unreliable. Now, while consensus is not science and never will be, it is the case that there are numerous scientists, even those who do hold to a belief in God and who are in a saving relationship with Jesus, who do sincerely attest to the reliability of the radiometric dating methods. So how would you address any concerns or objections to the test cases that you raised?
A common argument I keep saying is that the young Earth creationists don't know how to use these methods. Well, let's give them the benefit of the doubt on that one. Let's say we don't know how to use these methods. Let's say we don't know how to understand them. So how about they take us behind the curtain? How do they show us how it's supposed to be done? Okay, so if we keep getting it wrong and we're trying to follow their literature, why can't they show us how to do it right? What's the correct way? And why are the young Earth creationists wrong when they use the same tactics to show the invalidity of their methods that the secularists use to validate them? And what I see is like is excuse after excuse after excuse. But again, what I don't see is actual doing. And I don't see them doing their own tests. So let's assume that these tests are wrong. Let's assume that what the young Earth creationists have brought up, let's assume that they're wrong. So how should they be done correctly? And then let's see if it's done correctly, and let's see it done correctly so that we can correct our errors. Okay, so that's what they should be doing to answer our objections. But all they're doing is just repeating their story. And I think I know why. It's because the science doesn't actually support them. And I think those in the know that it doesn't support it, but they're going to believe it anyway. But also, we're going to see later on, either today or tomorrow or both, is that they will literally change the data. And I mean that they will change the data. We're going to go through an example of this later on. Okay, but again, what we're not going to see is a demonstration of the science, nor going to see the scientists take us behind the curtains to publicly showcase that how their methods actually work.
So thank you for answering those objections about radiometric dating. And now that we've looked at them, for these last two questions, we're going to shift gears from radiometric dating. Besides radiometric dating, there's also carbon-14 dating. You mentioned this a little bit earlier. Now, does carbon-14 dating support the idea of the evolutionary eons timescale?
So carbon-14 it actually technically is one of the radiometric dating methods. Okay, but it belongs in a subcategory because it's one of the very few methods that we actually use for measuring recent and historical events. Okay, so that's the big that's kind of the big distinction, but it still follows the general radiometric dating principles. Okay, carbon-14 is still a radioactive isotope that still causes off radioactive decay, and it's being used as a dating method. But what it doesn't do is it doesn't showcase the deep time of millions of years. Okay, carbon-14 has a relatively speaking very short half-life, which is only 5,730 years, as opposed to millions of years, and it really can only be used up to 10 to 12 half-lives, which is 50 to 70,000 years. Okay, carbon-14 is used to date bones, pottery, plants, and pretty much anything that could absorb carbon-14. So again, there are a number of creationists who confuse this, but there are some secularists that do as well. But carbon-14 isn't used for actually determining the age of the Earth. Okay, and again, it's a misconception that I hear from both parties. But that said, it still is a radioactive decay. It just doesn't deal with deep time because it doesn't last that long. This method has been used extensively to showcase historical people, historical events, when societies lived. But it's also been used for testing some of the other methods. Okay, so we find things like wood, coal, unfossilized dinosaur bones, and then but according to the big methods, these got to be at least multi-millions of years old because the rock layers that they're found in are radiometric dated to be multi-million years old. But if that's the case, we could use carbon dating as another test case to see if these methods are actually giving accurate results. And again, key thing here is that carbon-14 can't date anything older than 70,000 years, really at best 100,000 years, given the best scenarios. So with the RATE team, John Baumgartner did probably the most powerful study from the RATE project. And what he tested was numerous coal seams and diamonds, each purported to be hundreds of millions of years old. Diamonds were like 1 to 2 billion years old, and then coals were like 100 million to 300 million years old. So since these things have carbon in it, let's see if they will test out for carbon dating, or if they would give up datable carbon results. So that was the idea. So when he tested these coal seams, when he tested these diamonds, and diamonds are the hardest known material, and so getting any kind of leaching of the carbon leaking in and out would be very difficult. And what each result came back with is excessive measurable amounts of carbon-14 and well above any kind of contamination levels. Okay, and any of the standard contamination that they should be seeing should be calibrated in the machines. Okay, so that should be a measurable, testable, known error factor that should be calibrated. Okay, if you're going to weigh something, and you have like a pan that holds it, your weigh scale is going to include that pan or that tray, and so you have to calibrate your tray, your weigh scale to take out the mass of that tray. The same would be true for carbon-14. Okay, so but not only did these results come back with high levels of carbon-14, they came back with the same range of carbon-14. Okay, and that's a big thing here. So it gets better. So Brian Thomas and Vance Nelson published in 2000 in the Creation Research Science Quarterly in 2015. They did a study of 16 different dinosaur bones from all over the world and from different layers and depths. And each of these bones, with no correlation between each other, came back with dates ranging between 15,000 and 55,000 years old. Each of these are supposed to be 65 million years or older. But carbon is showing them to be 15 to 55K years old, 55,000 years old. So, and because there's no correlation, what this shows is that all of these things were laid down at the same time. So skeptics will say, well, that's older than 6,000 years, therefore young Earth creation is still invalid. Well, that's not necessarily so. In 1975, okay, so again, this is almost 50 years ago, A.E. Wilder Smith, who's a not so well-known creationist, he had 3 earned PhDs in chemistry. Brilliant guy, and he needs to be respected a lot more in the creation circles. But he wrote the book, "The Natural Sciences Know Nothing of Evolution," a book that has no valid refutation against it. Okay, very powerful book. But one of the things he points out in this book is that carbon-14 is produced by radiation in the atmosphere. Okay, and this is well known. But that radiation gets through based on the strength of the Earth's magnetic field, which is getting weaker. So that means we had a stronger magnetic field a few thousand years ago. Stronger magnetic field means less radiation getting through. That means less carbon 14 produced. And so, based on the current techniques, that would make any object that is really more than 1 to 2,000 years, and I'm being generous here, automatically appear to be older than they actually are, because they didn't consume enough carbon 14 to match the current levels, which is based on the current radiation coming through on the sun with the current Earth's magnetic field. Okay, we have an event called the flood, which would have had a dramatic impact on the magnetic field, and also whatever kind of canopy was over the Earth in the pre-flood that made the entire world pretty much tropical, or at least somewhat tropical. And so little radiation would have gone in through that. And so anything that's within 6,000 years ago, 4,000 years ago, anything like that, there definitely would have been a lot less C14 than what is needed to compare with today. Okay, so something that perished in the flood, it would have the appearance of 10,000 of years old when it really was only 4,400 years old. Okay, so with this, one thing I want to point out here, one of the mistakes that I think that the RAID team made is that they try to account for billions of years of history into 6,000 years. Okay, so they saw how the scientists, the secular scientists, get these billions of years of data, but they made the assumption that the billions of years data is relatively accurate. Okay, or at least compared for their story. But we really don't have to answer for false data. Okay, so using the carbon 14 example here, if we have if our sample really is only 4,400 years old, because that's when it got buried with the flood, and the carbon dating would make it appear to be 15,000 to 5,500 years old, we actually don't have to account for how much condensing from 15 to 55K down to 4.4K. We don't have to account for all that because the older dates, the 15 to 55,000 years old data, actually doesn't exist. It's a calculation based on false data, false assumptions, and false calculations. So we actually don't have to account for their data fitting within our model. They have to demonstrate that their models are valid. And when you look at the science, fully investigate what's all involved with these methods, there's absolutely no reason anyone should trust these radiometric dating methods because there's way too many factors that they can't account for.
So in our last question, we just looked at how carbon-14 is actually more of an ally, it seems, to the creationary model than the evolutionary. Now, in what I've seen in creationist research, creation scientists, they'll sometimes use, I call them, I guess, alternative dating conventions, like, say, the presence of soft tissue in dinosaur bone as a metric to show how such things are inconsistent with the uniformitarian outlook. However, some will object to using these alternative dating conventions, ideas like radioactive dating of living snails or using the decay of the rings of Saturn. Is there a reason to prefer radiometric dating over other forms of dating?
I don't remember where Ken Ham posted it. I think it was in the. I think it may have been in the Ken Ham Bill Nye debate. But he made a comment, and he had a whole bunch of different like dating methods, and 90% of them showcase a very young Earth. Okay, it's only a select few models that showcase deep time and millions of years old, but that's the ones that everyone focuses on because that's what the media is trying to portray. And so again, it's the reason to prefer any dating method over another really comes down to the competing worldviews. Okay, and really it's the competing histories. Okay, it never really is about the science. And again, I mentioned this in the last session. Science is just a tool we use to engage our worldview and bring it to the physical world. The dating methods which demand uniformitarian principles, they can both support deep time and they can refute deep time. Okay, they could support creation, they could reject creation. So I'm always skeptical about people that use dating methods when they don't consider all the assumptions or all the factors that go into the equation. Okay, so we have seen things like dating living snails to be like 27,000 years old, mammoths where one side dates older than the other. And then here's a quote that came from a Creation Moments that was pretty funny. So So this was from a letter that went to Creation Moments on September 6, 2012. And it's quoted in Let God Create Your Day, Volume 8. So in 1973, the guy that wrote this letter was stationed in Hawaii at Kaneohe Bay Marine Corps Air Station on Oahu. He found some amber-like stuff oozing from a palm tree. Okay, emphasis on palm tree. Okay, there were not insects in it, and it was the consistency of chewed gum. So he took a little bit of it. It says about the size of a marble and put it into a film canister. Okay, again, this is 1973. Many years later, he came upon that film canister and found the resin to be harder than wood. On a fling, a friend of ours took it to the university where he worked and had it tested. The report came back that it was spruce amber and over 150,000 years old. He never did tell them the rest of the story. Okay, so not only did they get the tree wrong, they definitely got the age wrong. And so that's another test case. And we got lots of these. So one of the things that I've seen here, so Creation Moments, on Facebook, they posted an article about using the moon's recession rate to showcase the Earth-Moon system cannot be billions of years old, because if the moon is getting further and further away from us due to the orbit, that means it could not have been here billions of years ago, because it will be literally on top of our planet right now. And again, why be so selective when out of 100 possible methods that one could use, 90% of them indicate a younger Earth? And so here's the brass tacks. Here's the real reason. They actually don't care about the methods. They don't care about the results. What they care about is not 6,000 years. They care about any origins history other than the Bible. That's really what this is after. One thing that I challenge, that I put forth, if we had not witnessed Mount St. Helens erupt in 1980, if we didn't discover this mountain until 1996, okay, modern scientists would still proclaim it to be that 230 range to 3.4 million years range, age range. They would have accepted the dating results that Steve Austin gotten without question, if we did not have direct eyewitness testimony of when Mount St. Helens erupted. I do believe that that's what they would teach. So yeah, so your questions like, why do they prefer the radiometric dating to others? It's very simple. Radiometric dating supports the deep time story. It supports the agenda, the worldview that is intentionally created to question and challenge what the Word of God states.
And so we've now come to our final question. Earlier we spoke about how to determine the scientific rigor of a method. And now I'm wondering, how can Christians, through the strength of Christ, endure the rigorous trials of life that may come their way?
This is a very important question for our day and age, because one of the things that we have never dealt with in this place we call the United States of America is persecution. We have never dealt with persecution. We've never actually had our faith actually challenged. Okay, and so and if we had, it's only on an intellectual basis. Okay, so it's so this is a very important question that we're going to need to be able to answer here very soon, because persecution is coming. Okay, that is independent of what you believe about how God's going to bring about the end times. But this country, we're about to experience actual persecution upon the Christian church. So we got to be able to answer this question of how can we, through the strength of Christ, endure the rigors of the trials of life, and in a lot of cases, outright persecution. But there's no book or no belief that's ever been so thoroughly scrutinized in every line as the Bible. Yet in 2,000 years, all that skepticism has only has never produced a single thing that actually authentically refuted any statement in the Bible. There's no example of such a thing. H.L. Hastings 200 years ago describes the Bible as an anvil that has worn out many hammers. Okay, so my statement is that if the Bible could have been proven false at any time, it would have been 2,000 years ago. So how can we endure this kind of opposition? Okay, so we're talking about worldviews and looking for historical narratives for our worldview. And one of my other chapters, as I mentioned, is the testimony of the saints. Okay, so how could these men and women face extreme levels of torture and death and never give up the brethren, never renounce the name of Christ? How could they do that? And so, and you mentioned in your question, we do it through the strength of Christ. And let's be simple. That's how they did too. It was Christ who preserved them. And so all we have to do is focus our eyes on Christ, just as they did, and then nothing man can do to us is going to faze us. But I'm going to be writing a book on Proverbs 3:5, which states, trust in the Lord with all your heart and lean not on your own understanding. Okay. If I were to try to go into what I'm going to write about, that book will be here forever. But how do we endure? Trust God's word. It's really that simple. And I'm not really going to proclaim that's true just because that's my opinion. This book has proven itself and its validity over the past 2,000 years way better than I ever could. And the Bible has never failed. And the reason why is because its author has never failed. Its author is God himself. How can we endure? It's God who makes us endure. All we have to do is just believe him, trust him, and obey him. It's that simple.
Amen. Thank you very much for your time, Charlie. It was an absolute joy. And to our listeners, thank you very much for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find Charlie's website, his autobiographical information, his books and resources, and other creation links in the description below. Please share and subscribe to the Current Topics in Science podcast. It's available on iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.